There is a number so small that writing it down takes more space than the concept it represents deserves, and yet it contains an entire universe of consequence. At one particular surface surrounding every object with enough mass, a bracket in Carl Schwarzschild's line element goes to zero and then past it, past zero, into negative territory. It is the number zero. Not zero as in the absence of something, not zero as in nothing to see here, but zero as the value of a specific factor in a specific equation at a specific location in space. And that crossing, that transition from positive to negative of a single multiplicative factor in a single equation, is the entire difference between a universe you can navigate and a universe that navigates you. Outside the surface, the factor is positive. Time flows the way time flows in your living room. You can move in any spatial direction. You can sit still. You can choose. Inside the surface, the factor has flipped sign. The coordinate you would have called radial distance has become time. The coordinate you would have called time has become something you can stand still on. The freedom you associate with space has migrated from where you expected it to where you never expected it to be. This is not a metaphor. This is not a way of speaking about something too strange for ordinary language. This is what the equation says when you read the sign on each term. A factor changes sign. The labels on the coordinates swap. Time becomes a spatial direction. Space becomes the direction your future points. You have a sense right now, sitting wherever you are, of being at a particular place. The chair is in a room. The room is in a building or a landscape. The building or landscape is at a particular location on a particular planet orbiting a particular star. The coordinates that describe your position are in some sense obvious. You are somewhere in space, and you are at some moment in time. What you almost certainly have not thought about, because nobody prompts you to think about it in ordinary life, is why space and time feel so different from each other. Not just different in scale, different in character. Space extends in 3 directions, and you can move through any of them freely. You can walk east or west. You can go up or down. You can go forward or back. You have genuine choice about which spatial direction to move in. Time extends in one direction, and you cannot choose differently. You cannot move backward in time. You cannot stand still in time. You are carried through it at 1 second per second, regardless of anything you do. There is no temporal lever to pull that changes this. You are in time the way a river is in its channel. The space-time interval is the quantity physicists use to describe the separation between 2 events. 2 events being things that happen at specific places at specific times. The interval has the form of the spatial distances squared, summed across all 3 directions, minus the square of the time separation multiplied by the speed of light squared. Everything positive for space. 1 term negative for time. That is all. The spatial coordinates enter the formula with positive coefficients. The time coordinate enters with a negative coefficient. That sign difference, that single minus sign in front of the temporal term, is the geometric origin of the entire asymmetry you experience between space and time. With it, one direction has a special character. You cannot circle around in time the way you can circle around in space. You cannot return to an earlier time by traveling far enough in the time direction. The minus sign makes time a one-way road. All of physics, all of causality, all of the experience of being a creature embedded in a universe with a past and a future comes down to that sign. This is what makes what happens inside a black hole so profound. Because inside a black hole, the sign moves, the interval and its terms. In flat space-time, far from any gravitational source, the interval between two nearby events is given by a sum of 4 terms. The first 3 terms are positive: the square of the displacement in the x direction, the square of the displacement in the y direction, the square of the displacement in the z direction. The 4th term is negative: the square of the time displacement multiplied by the square of the speed of light, with a minus sign in front. The 4 terms together give a number, and the sign of that number tells you something fundamental about the relationship between the 2 events. Let us read the space-time interval carefully, because the careful reading is where everything lives. If the interval is negative, the 2 events are time-like separated. There is enough time between them relative to the distance that a signal moving slower than light could have connected them. The events could be causally related. One could be the cause of the other. If the interval is 0, the events are null separated. A photon traveling at exactly the speed of light could have connected them. Light, and only light, could bridge the gap. If the interval is positive, the events are space-like separated. They are too far apart in space for the available time to permit any signal to connect them. They cannot be causally related. Nothing could have traveled from one to the other. When the factor changes sign, the coefficient in front of the time term changes sign. The term that was negative becomes positive, and the coefficient in front of the radial term also changes sign through its own relationship to the factor. The term that was positive becomes negative. The time term, which had a negative coefficient, now has a positive coefficient. It looks like a space term. The radial term, which had a positive coefficient, now has a negative coefficient. It looks like a time term. The equation we are reading was not discovered by a team in a well-funded laboratory. It was not found through years of patient collaboration in a peacetime university. It was derived by one man in a tent on the Russian front in December 1915, between artillery calculations, in the same weeks that shells were falling a few hundred meters away. The labels have not changed. The coordinates are still called R and T, but the geometric character of those coordinates, which is entirely determined by the sign of their coefficients in the interval, has swapped. R behaves like time. T behaves like space. The minus sign has moved from one term to the other. The man who found it in a tent. Karl Schwarzschild was born in Frankfurt in 1873. By the time the First World War began, he was 40 years old and one of the most accomplished astronomers in Germany. He was director of the Astrophysical Observatory at Potsdam, a member of the Prussian Academy of Sciences, and a man with a comfortable house, a wife, 3 children, and every reason to remain in safety. He volunteered anyway. He served in the artillery, first in Belgium, then in France, then on the Eastern Front. His job was to compute trajectories, the mathematics of where shells would land if fired at a given angle and velocity. In November 1915, Albert Einstein delivered the final form of his field equations to the Prussian Academy of Sciences. The equations describe how matter and energy determine the curvature of space-time, and how that curvature determines how matter and energy move. Einstein himself did not have an exact solution. he had approximations. He had verified that his equations predicted the observed precession of Mercury's orbit, but the precise geometry around even the simplest possible object, a single, motionless, perfectly spherical mass, he had not written down. Schwarzschild read Einstein's November papers as soon as they reached the front. He worked out the exact solution in less than 4 weeks. He wrote a letter to Einstein on December 22, 1915, enclosing his result. The letter contains a sentence I think about often. He wrote that the war had been kind enough to him to allow, in the intervals between fighting, a walk through your land of ideas. A walk through your land of ideas, written in a tent, in winter, with shells falling nearby. Schwarzschild never saw what was inside it. He contracted a rare autoimmune disease while on the Russian front, was sent home to a hospital in Potsdam, and died there on May 11, 1916. He was 42 years old. His solution had been in print for a few months. The equation he derived contains the swap, the factor that changes sign, the bracket that goes from positive to negative at the Schwarzschild radius, was sitting in his paper in January 1916, but neither he nor anyone else recognized what it meant. The community's consensus for decades was that the surface where the bracket vanished was a mathematical singularity, a place where the theory broke down, a boundary physics could not cross. It took 44 years, from Schwarzschild's letter to the decisive work of Kruskal and Shekeres in 1960, for the physics community to read the equation that had been sitting in front of them since the winter of the First World War. The equation did not change. What changed was the willingness to take it seriously. Reading the Schwarzschild metric. The Schwarzschild line element is the equation that gives you the space-time interval in the curved geometry surrounding a spherical mass. It has 4 terms, as the flat space-time interval does. The angular terms, corresponding to movement in latitude and longitude around the sphere, are the same as in flat space. They do not carry the drama. The drama lives entirely in the first 2 terms. The first term is the time term. Its coefficient is minus the quantity 1 minus the Schwarzschild radius, divided by r, multiplied by the speed of light squared. The Schwarzschild radius appears here as RIS, and it is equal to 2 times Newton's gravitational constant times the mass of the central object, divided by the speed of light squared. Stop and look at the bracket. Outside the Schwarzschild radius, where r is greater than rs, the fraction rs over r is less than 1. 1 minus something less than 1 is positive. The bracket is positive. The second term is the radial term. Its coefficient is the reciprocal of that same quantity. 1 divided by the bracket 1 minus rs over r, at the Schwarzschild radius exactly, where r equals rs. The fraction rs over r is exactly 1. 1 minus 1 is 0. The bracket vanishes. Now carry this through the 2 terms. Inside the Schwarzschild radius, where r is less than rs, the fraction rs over r is greater than 1. 1 minus something greater than 1 is negative. The bracket is negative. Inside, the bracket is negative. So 1 divided by a negative number is negative. The radial term now has a negative coefficient. The r coordinate has acquired temporal character. It now carries the minus sign that t carried outside. That is the entire swap, no new physics, no exotic matter, no exotic mechanism. The same equation, evaluated at r less than rs instead of r greater than rs. The bracket changes sign, the coefficients change sign, the geometric character of the coordinates changes accordingly. R is time. T is space. What tipping light cones mean in your body? A light cone is the set of all events that could, in principle, be causally connected to a given event. The future light cone is the set of all events that a signal emitted from here and now could possibly reach. The past light cone is the set of all events from which a signal could have reached here and now. The light cone is bounded by photons moving at exactly the speed of light. Anything that travels slower than light, which is everything that carries mass, everything that carries information, everything that constitutes causal influence, must stay within the light cone. There is a second language for describing the same fact. It does not use the metric and its signs. It uses light cones, and the light cone language is worth dwelling on because it translates the abstract sign flip into something you can feel. Inside the Schwarzschild radius, both edges of the future light cone point inward. The entire future wedge, every direction in your future, every direction a slower than light signal can travel, every direction your world line can take, points toward smaller r. There is no future pointing direction with increasing r. The light cone has tipped past the point where any outward direction remains accessible. At exactly the Schwarzschild radius, something decisive happens. The outward edge of the future light cone, the edge pointing away from the mass, tips until it is exactly parallel to the horizon. A photon emitted precisely radially outward at the event horizon moves along the horizon forever. It neither falls in nor escapes. It runs at the speed of light in a direction that carries it exactly nowhere in radial terms. And now, here is what that means in your body. You have a body. Your body has a future. Your future is bounded by what you can causally reach. The boundary of what you can causally reach is defined by the local light cone. Your future is, in the deepest sense, the interior of your local light cone. Inside a black hole, the local future light cone points inward. Your future, defined geometrically and causally, points toward smaller r. You cannot redirect your body's world line to have increasing r because there is no future pointing direction in which r increases. The geometry forbids it not by applying force, but by eliminating the possibility. This is not gravity in the conventional sense, the way a weight holds you to a chair. This is something more fundamental. The very structure of what counts as your future has been rotated. Your future used to point in the time direction. Inside the Schwarzschild radius, your future points in the radial direction. The singularity at r equals 0 is not a place at the end of a spatial journey. It is a moment at the end of a temporal one. The Schwarzschild radius has a number. The singularity is your future, not the place your future is pointing toward. Your future itself, the locus of events that every causally permitted path from your current location must eventually reach. Abstract geometry becomes more real when numbers attach to it. For an object with the mass of the Sun, the Schwarzschild radius is approximately 2.95 kilometers. The actual radius of the Sun is about 696,000 kilometers. The Sun is enormous compared to its Schwarzschild radius. To create a black hole from the Sun, you would need to compress all its mass into a sphere less than 6 kilometers across. The Sun is not a black hole. Its surface sits far outside the region where the coordinate swap occurs. For the Earth, the Schwarzschild radius is about 8.9 millimeters, the size of a marble. All of Earth's mass, every ocean and continent and piece of iron in the core, would need to be compressed into a marble to form a black hole. The Earth is also not a black hole. For M87 star, the supermassive black hole at the center of the galaxy, M87, the mass is approximately 6.5 billion solar masses. The Schwarzschild radius is approximately 19 billion kilometers, about 127 astronomical units. The outermost planet in our solar system, Neptune, orbits at roughly 30 astronomical units. M87 star's event horizon, placed at our Sun, would extend far past every planet and deep into the outer solar system. These are real objects. The Schwarzschild radii attached to them are the locations of real surfaces at which the coordinate swap actually occurs. Inside those surfaces right now, the coordinate that plays the role of time is r, and the coordinate that plays the role of space is what Schwarzschild called t. The numbers make this tactile in a way the abstract derivation does not. Sagittarius A star is 26,000 light-years from where you are sitting. Inside a surface 12 million kilometers across at its center, the geometry has rotated. R is the clock. The singularity is the future. For the next several decades, the standard interpretation was that the surface at R equals Rs was a physical singularity. The place where the equations broke down. The place where the laws of physics stopped applying. This was not an unreasonable initial reading. Mathematical singularities, places where quantities diverge or vanish pathologically, usually do indicate breakdowns. The standard move when you encounter a singularity in an equation is to treat it as a boundary condition rather than a feature. Einstein himself contributed to the confusion. In a 1939 paper published in the Annals of Mathematics, he argued on physical grounds that real matter could never be compressed below its own Schwarzschild radius. His argument was essentially that the particles making up any physical object would need to move at or above the speed of light to maintain stable configurations below Rs, and since this is forbidden, no real collapse to a black hole could occur. The argument was wrong, but it was wrong in a specific and subtle way. It was correct for static configurations. It missed entirely the dynamical case, the case where a massive star runs out of nuclear fuel and begins to collapse under its own gravity. There is no law that prevents such a collapse from proceeding past Rs. The collapse does not need the particles inside to maintain any particular configuration. The collapse happens because gravity wins and nothing stops it. Einstein and Oppenheimer, published in the same year. Einstein's result received more attention. Oppenheimer moved into wartime work on nuclear weapons shortly afterward, and his cosmological result was largely set aside for over a decade. In the same year, 1939, Robert Oppenheimer and Hartland Snyder showed exactly this. In a paper published in Physical Review, they followed the geometry of a collapsing, spherical dust cloud through its own Schwarzschild radius, and showed that the mathematics was perfectly well behaved there. The apparent singularity at Rs was not a physical pathology. It was an artifact of the coordinate system. Arthur Eddington, the British astronomer, had already, in 1924, written down a coordinate transformation that removed the apparent singularity at the Schwarzschild radius. He used what are now called ingoing Eddington-Finkelstein coordinates, a coordinate system in which the horizon is perfectly regular, and which makes the one-way character of the surface visible. He wrote it down and did not realize what it meant. He used the transformation as a technical convenience and moved on. Then, in 1960, independently and within months of each other, Martin Kruskal at Princeton and George Sekeres in Australia produced the complete coordinate system. Working in Kruskal-Sekeres coordinates, the entire Schwarzschild geometry, outside and inside the horizon, can be drawn on a single diagram with no singularities at the horizon, with the event horizon visible as a clean diagonal line, and with the singularity visible as a horizontal curve in the future. David Finkelstein, in a 1958 paper in Physical Review, finally read it. He recognized that the surface at RS is not a singularity, but a one-way membrane. You can cross it inward. You cannot cross it outward. The coordinate singularity that earlier workers had treated as a physical limit was an artifact of poor coordinate choices, not a feature of the geometry. This was the reading that had been sitting in Schwarzschild's equation since the winter of 1916. The same equation, the same signs, the same bracket. 44 years between the letter from the Russian front and the diagram that finally made the swap visible. The river. There is a third language for the swap, and it is the most physical of the three. It is due to Andrew Hamilton and Jason Lisle, who published a paper in the American Journal of Physics in 2008 titled The River Model of Black Holes. The idea is this: abandon the picture of space as a fixed stage on which things move. Replace it with the picture of space as a river, flowing radially inward toward the black hole at a speed that increases as you approach the center. The speed of the river at any radius is exactly the escape velocity at that radius, which in turn is the quantity you would calculate from Newtonian gravity, the square root of 2 times Newton's constant times the mass divided by r. Closer in, the river flows faster. The photon still moves at c through the local water, but the water's inward flow partially cancels the photon's outward motion. Net outward speed decreases. The climb becomes harder. At exactly the Schwarzschild radius, the river flows inward at exactly the speed of light. A photon emitted outward is now moving at c through water that is moving at c in the opposite direction. Net outward velocity, 0. The photon runs at full speed, going nowhere. It hangs at the horizon forever, neither escaping nor falling in, because the current exactly cancels its motion. Now watch what happens to the r coordinate in the river model. Outside the horizon, r is a label for how far you are from the center. You can be at a fixed r value. You can increase your r value. You can decrease it. R is a spatial coordinate because you have genuine choice about your position in it. Inside the Schwarzschild radius, the river flows faster than light. A photon emitted outward is moving at c through water that is moving inward faster than c. The photon's net motion is inward. Even light, the fastest thing that exists, is carried backward by the current. Inside the horizon, r only ever decreases for any physically realizable object. The river carries everything inward. Every future-pointing world line has decreasing ER. R is no longer a coordinate you can stay fixed in or move through freely. R is a direction you are being carried through at a rate determined by the geometry, and that rate is always in the same direction. That is temporal character. The feature that distinguishes a time coordinate from a space coordinate is precisely this. You cannot hold fixed your position in a time coordinate, and you cannot reverse your motion in it. Inside the black hole, R has those properties. R is time. The river is the picture of that temporal character made physical. If R is time inside a black hole, then the question, how long does the inside last, becomes tractable. The question is asking, what is the maximum elapsed proper time on any clock carried from the event horizon to the singularity? How long does the inside last? The answer comes directly from the Schwarzschild geometry. For a non-rotating, uncharged black hole, the maximum proper time on a freely falling clock from the moment of crossing the horizon to the moment of reaching the singularity is equal to pi times the gravitational constant times the mass divided by the speed of light cubed. This can be simplified to a useful rule: approximately 15.4 microseconds per solar mass. 1 solar mass, 15.4 microseconds. 10 solar masses, 154 microseconds. 1,000 solar masses, 15.4 milliseconds. But black holes come in a vast range of masses, and the formula is linear in mass. Every factor of 1,000 in mass is a factor of 1,000 in interior duration. For M, 87 star, 6.5 billion solar masses, approximately 27.8 hours, a little more than 1 day. For Ton, 618, one of the largest known black holes at roughly 66 billion solar masses, approximately 12 days. These numbers are, in their own way, remarkable. The largest black holes are the gentlest executioners. Their interiors are spacious and long-lasting. Their event horizons are wider than the solar system. The tidal forces at their horizons are gentle, because the horizon is so far from the center that the gradient of gravity across a person's body is negligible. The difference shows up only in the global structure. The R coordinate is now temporal. The future points inward. Every day that passes on your wristwatch corresponds to a decrease in R, and there is a maximum number of days remaining, given by the formula, achieved by a specific trajectory. That trajectory is free fall, the geodesic, the unaccelerated path, the path a body takes when no engines are firing and no forces are acting except the geometry itself. This is the opposite of every survival instinct. Every biological strategy for staying alive involves effort, motion, resistance. Inside a black hole, effort costs time. Resistance shortens what remains. The passive option, the option of stillness and surrender, is the option that gives you the most, what free fall is. The geometry is not cruel about this. It does not demand active surrender. It simply rewards it mathematically. Free fall is the longest path. Every deviation is shorter. The most you can do is choose the longest path, and the longest path requires nothing from you at all. There is a concept in general relativity called the geodesic, and it is worth pausing on because the word is doing more work than it might seem. In curved space, the analog of a straight line is a geodesic. A geodesic is the path that extremizes the interval between two events, the path that takes no unnecessary detours relative to the geometry of the space it lives in. In flat space-time, time-like geodesics are straight lines through four-dimensional space. In curved space-time, they are curved, bent by the curvature of the geometry. In flat space, The shortest path between 2 points is a straight line. This is a geometric fact, not a physical one. You can describe it without referring to forces or energies or masses. Straight lines are the paths of minimum length between endpoints in flat geometry. The equivalence principle, one of the foundational ideas of general relativity, says that the paths taken by freely falling bodies, bodies subject to no non-gravitational forces, are exactly the time-like geodesics of the space-time geometry. Gravity is not a force in the Newtonian sense. Gravity is what it looks like when you try to deviate from a geodesic, when you resist the natural path of the geometry. An apple falling from a tree is not being pulled by a force. It is following a geodesic in the curved space-time around Earth. The tree branch that held it was the non-geodesic part. The branch was exerting a real force, a contact force, that kept the apple off its natural geodesic. When the apple detaches, it stops being deflected and resumes the geodesic path. We call this falling, but from the geometry's perspective, it is the straightest possible motion. You, sitting in your chair, are not on a geodesic. You are being pushed upward by the normal force of the chair, which is preventing you from following the geodesic that would carry you through the floor and into the earth. Your weight is not the pull of gravity. Your weight is the force required to keep you off the geodesic. Astronauts in orbit are weightless, not because gravity has disappeared, but because they are in free fall, following the geodesic, experiencing no non-gravitational force. Now, inside a black hole, the geodesics all terminate at r equals 0. The natural paths of the geometry, the paths that require no force to follow, all lead to the singularity. Deviating from a geodesic inside a black hole requires a non-gravitational force, just as deviating from a geodesic outside one does. And inside, every deviation that requires force is a deviation toward a shorter, proper time. This is what freefall actually means in the interior, not passive surrender to an overwhelming enemy. The longest possible life on your own terms, with no effort required. You exist on the geodesic by default when you stop fighting the geometry. The geometry gives you in exchange everything it has to offer. Maximum duration before the future arrives in full. 2 photographs. The papers appeared in the Astrophysical Journal Letters, volume 875, in 6 parts. They derive the mass of M87 star from the observed ring size and find approximately 6.5 billion solar masses, consistent with independent measurements from stellar kinematics. The shape of the shadow matches the prediction of the Kerr metric, the rotating generalization of the Schwarzschild metric, within measurement uncertainties. The observed brightness asymmetry, brighter below than above, is consistent with the predicted effect of relativistic beaming from infalling plasma in the accretion disk. In September 2015, a different instrument heard a different signal. LIGO, the Laser Interferometer Gravitational Wave Observatory, detected the first gravitational wave event. 2 black holes, each roughly 30 solar masses, spiraling toward each other and merging at approximately 1.3 billion light-years from Earth. The signal lasted less than a second. It contained 3 phases: the inspiral, the merger, and the ringdown. The ringdown is what matters for our purposes. After the merger, the newly formed black hole oscillates, and the oscillations decay, radiating energy as gravitational waves at specific frequencies and decay rates. These frequencies and decay rates are predicted precisely by the Kerr geometry of the final black hole. They depend only on the mass and spin of the resulting object. If the geometry is Kerr, the frequencies are exactly predictable. If the geometry is something else, the frequencies deviate from the Kerr prediction. The ringdown of GW150914 matched the Kerr prediction. Every subsequent gravitational wave event matched. By the time of GWTC3, the catalog of detections through the third observing run, approximately 90 high-significance binary black hole mergers had been recorded, and in every case, the ringdown matched the predicted frequencies of the final Kerr black hole. The instruments have confirmed that the geometry is correct wherever the geometry can be confirmed. The interior cannot be confirmed by external observation and never will be. But the interior is described by the same equation whose exterior has been photographed and heard to ring at the predicted frequencies. In January 2025, the event designated GW250114 was recorded. The signal had a signal-to-noise ratio of 77 to 80, the highest ever detected. The ringdown contained for the first time at statistically meaningful confidence the first overtone of the Kerr quasi-normal mode spectrum. The overtone frequencies match the Kerr prediction to 4.1 sigma. This constitutes the most stringent single-event test of the geometry of black holes ever performed, and the geometry passed. The swap is real. It happens inside objects we have photographed. It happens 26,000 light-years away from where you are sitting, inside a real object that the Event Horizon Telescope imaged in 2022, the future that has a shape. Let us come back to where we started. The difference is a minus sign. That is all. A sign in front of one term in the space-time interval. Negative for time, positive for space, in your neighborhood, at your location, in the geometry you inhabit right now. The sign is not a philosophical stipulation. It is a measurable geometric feature of the space-time you are in, and it is not universal. You are sitting somewhere. The chair is at a place. The minutes are passing. The difference between these two things, between the chair being somewhere and the minutes being somewhen, feels self-evident. Space is the stage. Time is the music. They are different kinds of things, and the difference has always been obvious. At a specific surface around every object, massive enough to form one, the sign moves. The factor that multiplies the time term in the Schwarzschild metric changes from positive to negative as you cross the event horizon. The factor that multiplies the radial term changes from positive to negative. The time term acquires spatial character. The radial term acquires temporal character. The labels stay the same. The geometry does not. The second was light cones. Outside, the future cone opens upward in time with a spatial bias toward the mass. At the horizon, the outward edge of the cone tips to vertical. Inside, the entire cone points inward in the radial direction. Every future-pointing direction points toward smaller r. There is no outward future. We have described this swap in 3 languages. The third was the river. Space flows inward. At the horizon, it flows at the speed of light. Inside, it flows faster than light. Nothing can swim upstream against a superluminal current. R decreases for every physical object. R is time. The equation did not change in those 44 years. The people changed. The willingness to take the sign seriously changed. The willingness to say, when the bracket changes sign, the coordinates trade roles, and what was time is now space, and what was space is now time. And the singularity that looks like a place in the original coordinates is actually a moment in the future of every interior world line. That willingness took 44 years to arrive, but the sign flip has a weight that the textbook treatment does not always convey. It is not merely a mathematical curiosity. It is not merely an interesting consequence of differential geometry. It is the geometric origin of what a future is, and it is telling you that the future is local, inside the event horizon of Sagittarius. A star, right now, at this moment, a real physical geometry exists in which the r-coordinate is the time direction and the t-coordinate is spatial. In there, time is distance, and distance is time. The past and future are organized differently. The future is inward. The future terminates at r equals 0. Somewhere in the universe, there are regions where the chair could not be a chair, where the chair would be a moment, where the room would be a duration, where your sense of where you are sitting would be replaced by a sense of when you are sitting, and the two would not be distinguishable. A minus sign in an equation, the same minus sign that separates time from space, the minus sign that carries the entire causal structure of the universe, a sign that in one specific kind of location has moved from one term to another, and in moving has rotated the future, made time into space and space into time, made the singularity a moment instead of a place, made the longest path the path of surrender. The chair is still a chair. The room is still a room. The minutes are still passing. And somewhere else in the universe they are not. Sleep well if you are sleeping. Drift slowly if you are drifting. The sign in your neighborhood is where it has always been. The chair will hold. The geometry will hold. You have been watching the entire history of the universe. Do not forget to like and subscribe and leave a comment to tell us what you think. Thanks for watching, and we will see you next time.